Parameters is a way to think about the complexity of a machine learning model. The more parameters, the more complex, and the more complex predictions it can make. The state-of-the-art models today have in the order of trillions, single-digit trillions parameters. The number of transistors in chips is not growing as fast. And so what is happening is that we're starting to see a discrepancy between the rate of growth of the complexity of these models and the performance increase of GPUs. And the consequence of this is that training a model is becoming more expensive as we move to subsequent generations. A parameter can be thought of as a knob that helps us make the model more precise in one direction or another. So to simplify the idea, we can imagine a model that is trying to distinguish between dogs and cats. And there could be a knob that refers to whether the ears are pointy or rounded. So cats have pointy ears and dogs have rounded ears. And by adjusting that knob, we can classify an image into whether it's a dog or a cat. Now, as we add more things that we want to classify against, for example, all animals, all objects, then we need more and more parameters. So to achieve supremacy at this task of image classification in 2012, we require 50 million parameters, and that comes with a need for extensive computation. And prior to that, the amount of computation required to do that was expensive or rare, whereas thanks to graphic processing units that became available. So the team behind AlexNet actually used a GPU, a couple GPUs on a gaming rig, and they were able to train that model. Since then, computational capability has improved, and so we've been able to build larger models. So for example, artificial intelligence achieved supremacy at machine translation in 2016, and that required a model that was 500 million parameters. And then when we look at something like GPT-3, that had about 173 billion parameters. And then when we look at something like GPT-4, it's not published, but the thinking is that it was about 10 times as many parameters as GPT-3. And so as we have progressed in the number of parameters that we can support, these models have been able to accomplish progressively more interesting tasks.